All right, so let's get to application problems. And we're going to basically do the same thing, except now we have some words to go along with it. So it says an object is dropped off a building, ignoring air resistance. The height above the ground t seconds after being dropped is given by the function h of t equals negative 16 t squared plus 100 feet. Use the limit definition of derivative to find the rate of change equation for the height. And this is, again, using the algebraic method. Okay, so what do we need to do? We need to find that point. So that's going to be, oops, not x, but t. I'll change probably eventually, but it's going to be t to start with here. So it's going to be t comma negative 16t squared plus 100. And then we find that close point. And again, that's going to be t plus h comma negative 16 times t plus h squared plus 100. Now we have to square that and take it times 16. So that's going to be our negative 16. Negative 16 times, when we square that, that's going to be t squared, and plus 2, let's do th, and then plus h squared. And so that's going to be a negative 16t, oops, t squared, and then minus 32th minus 16h squared. Okay, and then plus 100 when we get that. So now we'll add that in, and so we have t plus h, negative 16t squared minus 32th minus 16h squared plus 100. Okay. Now we're ready to do the derivative using the limit definition. So this is h, so we're going to look for h prime of t is equal to our limit as h goes to 0 of, now we plug that in first, minus 16t squared minus 32th minus 16h squared plus 100 minus, now I'm just going to put the parentheses here, minus 16t squared plus 100 all over h. Okay. Well, that gives us the limit as h goes to 0 of negative 16t squared minus 32th minus 16 h squared plus 100, then plus 16t squared minus 100 all over h. Now, what cancels? Well, we have a plus and a minus 16t and a plus and minus 100. And so let's go up here and say, okay, well, that's equal to, now we have, both of those have an h in it. So let's pull out the h. And that gives us negative 32t and then minus 16h, and then all over h. So if we take and cancel those or make h over h equal to 1, then that gives us the limit of h goes to 0 of negative 32t minus 16h. Now, if we plug in 0 here for h, well, that goes to 0. So all we're left with is a negative 32t, and that's going to be our h prime of t. So that's kind of, let's put it on this side, that's h prime of t. Okay, so that is our derivative, which is what they wanted for part A. Okay. Now, use the answer in part A to determine how rapidly the object is falling after 1 second. All right, well, what we can do is then we say, okay, h prime of 1 equals negative 32 times 1, and that's going to be negative 32, and it's, oh, well, this one actually has units. We should probably put this. What is the units here? Well, it's feet, and it's per second. So this one is uh, feet per second. We kind of left off our units there on that one. And so then if we take negative 32t replaced with 1 feet per second times 1 second, that's going to give us the final value, which is going to be negative 32 feet per second. Okay. So that's plugging it in and getting us the actual value there. And so does it say interpret? Well, no, it doesn't. But we can say after 1 second, the object is falling at a rate of 32 feet per second. Okay, so it's going down, of course, and so that's why it has a negative direction, but it's falling at 32 feet per second. So falling would be the negative part of it at a rate of 32 feet per second. Okay. All right, so I think we have everything once we finally labeled our H prime properly. And so again, that's going to be our rate that is moving for the feet per second here. All right, so let's stop there and we'll come back with another application.